Okay, so some absolutely bombshell news just dropped that has completely shaken the tech world. It looks like the intel is correct. China has pulled off a secret multi-year project to copy one of the most fiercely protected technologies on the entire planet.
And that's the billion-dollar question, isn't it? Did they actually do it? We're diving into a story of incredible ambition, intense technological blockades, and what frankly looks a lot like a high-tech heist. So how on earth did we get here?
You see, for years, China was completely locked out, systematically blocked from getting the world's most advanced chip-making tools. So what do you do when you can't buy the key to the future? Well, it looks like China's answer was to just build their own key, in secret. To really wrap our heads around this, we have to understand the immense pressure cooker China was in. This wasn't just some friendly business competition. Oh no, this was a full-blown technological blockade, specifically designed to stop its rise. And this right here, this lays out the problem perfectly. On one hand, you've got Beijing's massive goal to become the undisputed world leader in AI. But on the other hand, that entire ambition slams into a giant brick wall because the most powerful AI needs the most powerful chips, the very chips China was forbidden to buy. And this wasn't just one little hurdle. It was a coordinated fortress of sanctions. The US government cut off sales of top AI chips from companies like NVIDIA. Key allies like Taiwan and South Korea, who are the giants of chip manufacturing, were also pressured to restrict supply. But the real keystone holding this whole blockade together was one single, irreplaceable machine. And that brings us to a company called ASML. Now, you may have never heard of them, but they might just be the most important tech company on Earth. And here's the wild part. They don't make a single chip. No, they build the one machine that everyone else depends on to make their chips. Here's the bottom line. ASML has a total global monopoly on a technology called extreme ultraviolet lithography, or EUV. Think of it as the magic wand for making the world's best microchips. It's the only way to do it. And Washington went to extraordinary lengths to make sure that magic wand never fell into China's hands.
Okay, so to really get why this one machine is such a big deal, we need to talk about the nanometer race. It sounds complicated, I know, but it really just boils down to one simple, powerful idea. Smaller is better.
But to understand this battlefield, you have to think on a scale that's just almost impossible to imagine. A nanometer is 1/1,000,000th of a millimeter. We are talking about a level of precision that literally pushes the known boundaries of physics. To put that into perspective for you, in the space of a single nanometer, you could mine up about 10 hydrogen atoms. Think about that. This isn't just manufacturing. It's engineering on an atomic level. That's the kind of precision you need just to compete. So how in the world does it work? Well, you start with a disk of ultra-pure silicon, which is basically just super clean sand. Then comes the magic. An EUV machine uses that special light like a hyper-precise stencil, carving billions of tiny pathways onto the silicon. It is truly one of the most complex manufacturing processes humans have ever created. So China was blocked from buying the key. They hit a wall. So they decided to activate a new plan. It's being called a Manhattan Project for Chips, a top-secret national priority to not just invent, but to replicate this forbidden technology. And according to intelligence reports, this was a long, secret mission. It all kicked off around 2019. It was a 6-year project led by their tech giants Huawei and SMIC with one single objective: reverse engineer and copy ASML's crown jewel. And the goal? Start mass production by 2026. And they were aggressive about it. China reportedly went on a global talent hunt, poaching top engineers from the best of the best: ASML, TSMC, Samsung. The offers were staggering. We're talking huge salaries, multi-million-dollar bonuses, even luxury villas. They weren't just trying to build a machine. They were trying to buy the brains that built the original. And then came the bombshell, straight from a Dutch intelligence report, no less. And the confirmation was chilling. It said, quote, "The Chinese have successfully copied the 3nm EUV machines, and they're already operational in a laboratory environment." This isn't just a theory anymore. But hold on, this is where the story gets really complicated, because as incredible as this breakthrough is, it is not checkmate, not even close. You see, having the machine is one thing, but using it effectively, that is a whole different ballgame. And that brings us to this crucial idea of manufacturing yield. Think of it like this.
You might have the world's greatest recipe for a cake, but if only 1 out of every 5 cakes you bake is actually edible, you have a massive, wasteful problem. That's low yield. And from what we're hearing, that's China's biggest weakness right now. Let's just put all this into perspective. By 2026, when China hopes to start mass producing its 3 nanometer chips, its rivals like TSMC and Samsung are already planning to be mass producing the next generation, 2 nanometer chips. So even with this huge success, China is still playing catch up. They're still 1 generation behind. So, what does this all mean for the future? Well, one thing is crystal clear. The great chip race just got a new, very determined competitor, and the entire global tech landscape might be on the verge of a dramatic change. And the political will behind this is just immense. Beijing has set a legally binding national goal. By the end of 2027, 70% of all the chips used in China must be made in China. This has gone from being a secret project to a full-blown national crusade for technological independence. So China has fought its way to the starting line of the world's most advanced technology race. But just getting to the starting line is one thing. Winning is another entirely. The real challenge for them now is mastering efficiency and innovation, all while their rivals are already sprinting ahead into the next generation. The blockade might be broken, but the race to win the future, it's really just getting started.